Hello, welcome to Nikolai's genetics lessons, and today problem is: imagine you are a genetic counselor and a couple planning to start a family came to you for information. Charles was married once before, and he and his wife, his first wife, had a child who had cystic fibrosis, and the brother of his current wife, Elaine, died of cystic fibrosis. What is the probability that Charles and Elaine will have a baby with cystic fibrosis? Neither Charles or Elaine has the disease. As usual, I recommend you to stop video here, try to solve this problem on your own first, and when you would be ready, you can run video again and you can compare your answer with my answer and explanation. So what we are going to do for the start, let's analyze genotype of the Charles, and we have enough information to tell for sure what the genotype Charles belonged. And so Charles was married once before, and he and his first wife had a child who has cystic fibrosis. What this tell us? That tell us that Charles and his first wife were phenotypically normal, but had a child who had cystic fibrosis. Cystic fibrosis is recessive genetic disorder, and that means that he have to have two alleles in order to express this genetic disorder. So one allele he have to get from his father's side, and one allele he have to get from his mother's side. And because neither of them are affected with this genetic disorder, we can conclude that the genotype is heterozygous. So his first wife were capital A small a genotype, and Charles also were capital A small a genotype. So both of them were carriers of this genetic disorder, but were unaffected with this genetic disorder because both of them had one normal allele to balance one recessive allele. And as you see, when we build a Punnett square, we see that two normal people who is heterozygous for this genetic disorder may produce offspring that is going to be affected. So now we know that Charles' genotype is heterozygous, and we can be sure about this 100%. So now let's consider the genotype of his current wife, Ellen, and what we know about her, that the brother of his current wife, Ellen, died of cystic fibrosis. So let's now build a pedigree for his wife. So circle to designate his wife, and this is her brother. We connect them, and her brother died from this genetic disorder, and that give us his genotype that were small a, and of course they had parents who were normal. So that means that both of them were carriers, and the genotype were capital A small a and capital A small a. So the question is, what is the genotype of the allele? And once again, this table would help us to answer this question, because she doesn't express this genetic disorder, and by the time of her marriage she should express this genetic disorder, so she doesn't belong to this group, and that's for sure also. She have to belong to this group, so she is phenotypically normal, but as you see, within this group her chances is 2 out of 3 to be heterozygous. To be heterozygous, and that means to be able to give her progeny this recessive allele. So we can conclude that her chances is 2 out of 3. So 2 out of 3, 2/3. So now final step in our calculations. Once again, if we build a new Punnett square, and here we will list genotype of Charles, and the genotype would be capital A and small a, and we know for sure that this is his genotype, and here we would list genotype of his wife Ellen, and her genotype also capital A small a, but this time we are not sure about this genotype. We can say only that the probability that she has this genotype would be 2/3, or we also can say that this is 66.6% or 0.66. On the all these numbers are the same, just on the different scales. So now we build a Punnett square, and now we can predict probabilities for them to have affected child. So if this is going to be a genotype of the Charles, so here is a sign for male, so this is male. Male can produce 2 types of sperm. So imagine that he can produce haploid sperm. So instead of 2 A's in the sperm, we can find 1 A, whether this variant or this variant. So what we can say about the probabilities that sperm would be with dominant allele, we can say that the probability would be 0.5%, 0.5, and probability that sperm would be with defective allele, and we can say that the probability is also 0.5. Because we are sure about his genotype, we know that genotype is capital A small a, but here alien genotype we only can be sure about 2/3 or 66.6% that she is heterozygous. So because here I used this scale where 1 equal to 100%, I would use the same scale for alien. So I would use this number, and what is the probability that she would produce XL, that is going to be with normal allele, and this would be the half of this number. So this is going to be 0.33, and probability that she would produce gamete or XL with defective allele also would be 0.33. So now we have just to multiply all these probabilities in order to find the probabilities, for example, for these parents to have a child who is going to be completely normal, and the probability would be 0.5 for the allele from the child's side, and 0.33 for the probability to get a normal allele from the alien side. So we have to multiply these two probabilities, and the same is here, capital A small a, and this is going to be 0.5 and 0.33, and here we would have capital A and small a genotype, and variant would be 0.33 to get this normal allele from the alien side, and 0.5 in order to get this defective allele from the child side, and here we have probability to get a child who is going to be who is going to have both recessive alleles, and he would express this genetic disorder, and probability would be once again 0.5 from the to get this recessive allele from the child side, and 0.33 to get this recessive allele from the mother side. So we can now calculate the probabilities. So anything divided or anything multiplied by 0.5 is the same like we would divide this number by 2. So roughly we can say that the probability that they would have affected child that belongs to this genotype would be 0.165 on the scale between 0 and 1, and on the scale between 0 and 100%, this is going to be 16.5%. And this is basically all for today. Thank you for your attention. Please subscribe for my new videos that I post almost every day. Thumbs up if you like this video. Please write your comments, questions if you have any, and see you in the next video. Goodbye.